All right, so we're going to get started. Thank you. So we're going to talk about API security. And you're going to see the presentation is within two parts, right? One is deep visibility, and the second part is attack detection. So let me first start by talking about some of the recent, very, I would say, those that get a lot of attention lately around the attacks. Facebook, you may have been aware of that one. 30 million accounts were literally taken over by hackers. USPS, 60 million accounts, and more. I'm not going to go through all of them. But what's really interesting in all of those cases is not that they were attacked, is that it took a very, very long time to detect the attacks. Facebook took 14 months. Google, 2 years. USPS, several months. And so the presentation will go into the why, right? Why that happens. The teams are really good, especially I can attest you, Facebook teams are quite good. It's a lack of visibility into the API traffic that leads to this very, very long time to detection. But APIs, and we'll talk about that obviously in detail, there's not much between a hacker and an API these days. And APIs are becoming a target for accessing data that you're not supposed to be able to access, typically. Or pictures. Instagram, another API mishap. Obviously, photos of celebrities were taken there and a pass. So we're going to talk about visibility, and we're going to be talking a lot about how to define yourself and how to get better at it. Okay, so the one thing I want to point your attention to is that those organizations that I just mentioned had a lot of security layers. It's not that they had nothing, but the fact is those hackers went through those security layers as if they were none. And there's a good reason for that. We're going to get into it. So the impact obviously is what you expect. A bank account taken over, a healthcare account taken over, photos stolen, data stolen, money transferred, and so forth. And these are all real examples, by the way. So when you look at this space, right, in terms of securing API infrastructure, digital transformation project, and then when we go ask people, right, C-level people, digital transformation officer, what do you have today, right? What's your problem? And typically, it's always the same answers. We don't know if we really know about all our APIs. There could be some APIs out there we don't know. That's keeping me up at night. Or we really cannot tell good from bad traffic. We're going to get back into this later. But bad traffic is not always a hacker trying to get to your infrastructure. Bad traffic can be many other things. We'll talk about that. But really, in general, people will tell you, once someone connects, I just don't know what they do anymore after that. I cannot get that fine-grained audit trail that I need to know exactly what people have done. So we'll talk about these few things, but one of the big things that came out recently in many of the CISO meetings that we've had is that you may have multiple gateways, you may have multiple API sets, but you don't have an ability to correlate or view the traffic across all the gateways. And so that came out a lot in recent discussions. So the presentation is really about how do you get there? How do we tackle this? What's our answer to that, right? And of course, the next thing is attacks. How can you detect a threat on an API, an attack on an API, and actually block it as it happens? Okay, so let's move on. When you look at API security today, it's essentially two things, right? Access control, OAuth, right? And a WAF. Now, the WAF built predominantly for a web infrastructure. So what do you need beyond that, right? And so API gateways will give you some more foundational layers like rate limiting, so someone cannot really abuse by sending a ton of stuff to your API. You have the encryption with TLS typically out there. And then you have the traditional, I'm giving you a token, I'm giving you access, and I'm leading you through. So what's missing, right? So ultimately what's missing is the ability to really recognize all of the APIs that are active on your network. And that's a big gap today, by the way. And it's kind of funny, we'll talk more about that later, but most teams don't realize how big of a problem that is until they deep dive into it. And then it's really about being able to identify pre-login and post-login attacks. And on a pre-login attacks, it means anything that has to do with a stolen cookie or stolen token or someone taking the identity of someone else to connect to an account. We'll talk about what we call API-specific DOS and DDoS attacks. Those are finely targeted attacks on APIs to just disrupt the service or take down the API. And then we'll talk about outright cyber attacks on an API. I'm targeting the infrastructure, I'm taking stuff out. But we'll talk more, especially in the first part, about visibility. So when I mention USPS, when I mention Instagram, when I mention Facebook, I told you I will explain more of how that's done. So this is how the guys do it, right? And this is literally the attacks that have successfully breached all those API infrastructure in the last 2 years. So I'm a hacker, I'm grabbing a bank account, I put $100 there, I download the mobile app, and then I start bypassing the UI, and I understand exactly how the traffic actually is behaving beyond that UI. And so I essentially reverse engineer the API logic. And then the idea for that is that now I'm going to be testing this API. I'm not on the UI anymore, right? I'm straight in control and data, testing the API until I find a way to get the API to give me data from someone else's accounts. And so I'll try everything. I'll change the identifier that they use for my account. I'll change the target name, try a whole bunch of stuff. And at one point, I'm going to find a way to get to the account while always looking like a normal user. And that's the thing you have to keep thinking. I'm an authorized user. I'm a normal user. I'm authenticated. I'm on a network while reverse engineering the API to get to the other accounts. So if you look at the attacks that T-Mobile, Verizon, USPS, and others, this was all done that way. In a Verizon attack, actually, the guys figured that if they switched the payloads from XML to JSON, they could bypass the security altogether. No more authentication to give you the data. And then they had access to every T-Mobile account. So it gives you an idea of what's happening out there. And then obviously from there, they take over everything else. So this happened to an insurance company in Italy last year that we know of, bank in Europe last year that we know of, healthcare providers that we know of, and all this, the one I just mentioned as well. This is really why all of the existing defenses don't work for us, right? Because normal user, normal account, but finding a way to get to all of the other accounts. So that's how it's done. But we'll talk about a few more, right? So, I'm sorry? Okay, yeah, I forgot. So we decided to intermix demo with slides. So I'm gonna pass this on to Dore here, who's gonna move to demo, and it's gonna launch a bunch of attacks. I'll go back to the presentation, and then we'll go back to the demo, showing you dashboard and screens and reports as well. So, all your story.
Great. So, what we're simulating here is an example of an API takeover attack. And so, in this case, I went in and queried my account, and you see here, I was A. Smith at anycompany.org. And it basically gave me all this information about my account. So I thought, interesting. It's checking to see if I'm equal to some name. Now, what I looked at, thought, well, maybe it gives me an opportunity to come in and target more stuff here. And so, in this case, what I want to do is develop the script where I've got a bunch of usernames that I think might exist here. Why don't I go in and see if I can get information about all those different usernames? And so, in terms of executing the attack, what I'm going to do here is put in place my same token that I used for this, so it's still the same account. I'm going to set this up so that what I'm able to do here is do an attack against it, and instead of going after one, I'm going to go after many different accounts. So basically, what I'm going to do is set up in Postman here this tool which allows me to execute an attack against multiple different APIs. And so what I'm going to do is, or actually multiple different accounts. So what I'm going to do here is run that script I just showed you, and I'm going to do it against, sorry, it's hard to see here, against the this company. So I'm going to run this attack. I'm going to do it for, let's say, 1,000 iterations. I'm going to do one every 2 seconds, because what I don't want to do here is
10,000, yeah.
what I don't want to do here is actually trigger anything that is suspicious. So I'll make it every 2 seconds I do a request.
And by the way, that's how the guys go beyond the rate limiting, right? So it's slow enough that no one sees anything.
So I'll go ahead and start this attack, and it starts going through here, and you can see here the first one, it took a look and looked for this user, and it's going to go on down, and we're just going to continue. So what we'll do here is switch back the presentation and just let this run for a while we attack the API.
Okay, and then we come back to that later. So can you switch back to the presentation? Okay, I'm going to go through these next 3 slides very quickly. But one thing you should know, right, other techniques hackers used are very simple. They'll keep hitting the API, probing the APIs, looking for errors. And they're looking for an error payload that will contain a debug trace. And typical debug trace have IP addresses and so forth, and that's what they start using to attack the API after. So probing, also called fuzzing on an API, is like the 101 of the hacking world on APIs. Okay? So then the next thing, obviously, is stolen identifier. I'm stealing a token. Or I'm putting a piece of Java on that desktop, telling the browser what to do with that token that's already there. I don't have to steal the token. I just have to tell the browser to work for me as a hacker. Easier, but it happens. So stolen cookie, stolen token, telling the browser to do something for me, all are about stealing the identity of someone. But once I'm there in a system, I look like that user. I don't look like a hacker. Okay? And then, obviously, the big impact is typically an account takeover and all the problem that you get from that. Okay, so I mentioned DDoS attacks. So this one surprises a lot of teams, right? You'll talk to an API team and say the site is down. 3 days, we can't stop anything. They have all of the DDoS and DOS hardware, firmware, software around. They cannot stop the attack because those attacks are finely targeted API attacks. So last year, this affected several airline reservation systems, hotel reservation systems, healthcare systems, and so forth. And it's very simple. I know the API. I understand how it works. I'm sending 3-4 requests, and I take down the service. And that's why it is not being detected by existing DOS and DDoS tools out there. Okay, and next, what we call the authorized user attack. So we talk about some of these already, right? The API takeover is an authorized user attack. It's the worst nightmare for anyone, right? It's a non-user, it's a valid user, it's a valid account. Where are the red flags? But the problem is this is what's used to really steal and take over the account itself. And it happens more than you think. Bank accounts and so forth are being taken over this way. So this is like looking for a needle in a haystack, right? And I'm bringing this up because very soon we're going to talk about how we use AI to actually recognize this bad traffic. You're looking for a needle in a haystack. You may have tens of thousands of simultaneous connections, and one of them is bad. How do you detect that? Okay, so let me introduce you to the solution that we built for the last almost 5 years now, PingIntelligence for APIs. So we use AI to monitor exactly how each API is accessed and used. So we can really, we have more slides on that coming up. So the key there is have that thorough understanding of all the behaviors in the API infrastructure so that we can give you the deep insight, the visibility into the traffic and what's happening and the APIs so that we can really recognize bad traffic from good traffic, threats and attacks, and do something about it. And then we'll talk about how we do all of this without having to write rules, policies, benefit of AI is all self-learn, and we'll talk about the deployment model. So the rest of the presentation will be in 3 sections. We're first going to talk about visibility, then about the detection of attacks, and then we'll talk about how that gets all deployed. Okay, so let's deep dive into visibility. So Dore is going to show you dashboards fairly soon. Visibility is about 2 things: recognizing and understanding APIs that are out there and all their URLs, and then having this deep audit trail-like visibility into everything that's going on the API infrastructure. Okay, and the key there, and this is really something we keep hearing a lot about knowing about good from bad traffic, right? Sorting out, this is all good, this is worrisome. Why is it not right? So we'll talk in a few minutes about how we actually do this and how we give you that visibility into it. But we'll talk about other things too, right? One of the biggest recurring problems, you have multiple clusters of gateways. You may have them in different data centers, and you don't have that single pane of glass to give you visibility across all of them. Okay, so dashboard, reports, forensic, compliance report, DevOps report. Dore will show you that during the demo. So when we're done with a few slides, we go back to the demo and we'll show you active reports. Okay, not yet. Thank you. Back. Okay, let me tell you what knowing about all your API is really important. Okay, so when we talk to teams, the #1 recurring problem they have is they know about all of the APIs that DevOps report. They have that. But they don't know when an API show up in the lab. And the guy who put that in the lab thinking it's safe is in the lab, but the lab is connected to the internet. By the way, I would say internal APIs, external APIs, it's all the same. It's not because it's an internal API that the hacker is not going to get to it. He will. So treat all the APIs as if they were external. But the biggest issue is versioning of APIs. So, and that happened also to Facebook a couple of years ago. That one was really, I would say, publicized, so I can talk about it. And what happened, right? Facebook bring in a new application, new API, leave the old API around, forget about it. Hacker find the API, hacker has access to all the accounts. It's a true story. This was an application that Facebook had built for their own employees to give each employee access to any account at Facebook. And versioning APIs and forgetting about an API that you left back for backward compatibility happens all the time. And so you see how we give you visibility, and we can show you all the time. As soon as an API is active, we'll bring it up on the dashboard, we'll bring it up in a report, you'll be aware of it. We also detect all of the URLs attached to each API, so you have complete visibility into it. So the API auto-discovery, we can do it across AWS CloudFront, for example, an Nginx mesh as well, any number of API gateways. We support 11 or so today. And our own ping access, which is an API access control product as well. All the traffic going through this mesh will be identified, APIs will be recognized, and then the definition for this API is built by the AI engine. And then the beauty of it is that we use those definitions we auto-build to actually auto-configure the system itself. So when you deploy something like this, you don't have to configure it. We auto-configure it on the fly. And remember before I said no rules, no policies, self-learn, no configuration. We can actually deploy the whole thing with literally one command as well. We'll get back to that. So the value in there is being aware at all time about all the APIs in the infrastructure. So you never get surprised. You always know what's going on. Okay? So the next thing is API activity. So here's a case, right, where you may have a bunch of gateways from the same vendor. More often than not, it's a bunch of gateways from different vendors because different business units, different data centers. And what you don't have is a way to unify the views of the traffic across all of those gateways. And by the way, it could be 20 gateways in one cluster from one vendor. It's the same thing. So we can give you the unified view of all of the APIs, traffic across all the clusters, across all the data centers. And by the way, we'll talk about the detection and the visibility soon, but all of the traffic across all the APIs actually goes into an AI engine, and we can actually establish correlation between the traffic across any of those gateways. So if you have traffic in Azure, traffic on-premise with an IBM gateway cluster, we will correlate those traffic together, looking for patterns. Okay, so obviously the number one goal is unified reporting, unified dashboard, single pane of glass, both for DevOps and for the security team, right? And we can give them the same views at the same time. And we have integration into a number of SIEMs. Of course, people think Splunk always first, but any SIEM we can integrate with. You can use Slack channel driven by Splunk to let you know that an attack just was detected and so forth. So there's a lot of built-in capability into the system. Okay, so do we go back to the demo right now, Dore? Okay, so Dore is going to show you a few reports, and those reports obviously include attack forensic and visibility. The visibility, remember, those attacks took so long to detect because of the lack of visibility. So the visibility piece first, and Dore, I'll let you take it over.
Okay. So we'll start by showing the dashboard. And what the dashboard does is provide a picture into all the APIs being monitored and their status. And so you can see from an AI perspective whether they're trained, the attack activity on a given API. The idea is to provide an ops team the visibility as to where attacks may be occurring so they can go drill down and get more insight into what actually occurred. So for a given API, you're able to then to drill down and get more information on that particular API, say the attack specifically on that. So you can see here this one has had a bunch of data exfiltration attacks as well as other types of attacks which have occurred on the API. And so you can see the information about those as well as other kinds of attacks. You're also able to see the number of particular clients. As you can see, this was all about IP addresses because depending on the type of API, maybe they use API keys to connect in. Maybe they're using a token. Maybe they're using usernames and the like. So depending on the API type, we can monitor different kinds of things to look for attacks on that API. And so this would show that. This graph would show the attack activity over time. So you can get a view of all the different attacks and when they're happening. Again, we did a pretty aggressive attack series on this, as you can see. But generally, you're going to see a much lower amount, hopefully, unless you're under a very heavy attack at all times. But the idea here is to show that activity in those attacks. You also can see the activity on given paths within your API, as well as the devices accessing other kinds of information. Other things you can do is, if you look at the bigger picture of things, is look at the activity across all the APIs. And one of the things that we also have is the ability to deploy decoy APIs or deception. And Bernard's going to talk about that a little bit later, but you're able to also look at a dashboard which provides information on all the decoy APIs and what has happened on those. And you can have either standalone decoy APIs where hitting it and every single path is a decoy, or you can have paths within an existing API, depending on how you're deployed. And so if a client hits that path, it could be a fake path, if you will. So the whole idea behind that is a hacker is the only individual who's going to access that, because a normal client would be using the programmed access to that API. They're not going to be clicking on things to figure out what happens. So that's basically the dashboard. If we could now maybe flip back to the presentation, we can go through. So in the presentation, what I'll do is talk about some of the reporting available. So one of the key things is providing insight into the activity reporting. So you're able to see all the activity on a given API. And this can be rolled up for compliance purposes, other kinds of things. So it'll show the discovered APIs in the environment and the detail of all the access on a given API. So you're able to see reporting about the paths access, the number of requests made, all this kind of details available and accessible via reports. So these reports can be ingested into other tools. They're actually used by our dashboard, provide insight into the API activity, and they allow you to roll up this information, compliance and other types of reports to provide assistance in your governance. If this information really complements the API gateways, which typically provide information, but it's at a higher level. So the idea is to provide that next level of detail, which helps fill in the gaps for the compliance reports and provides access to more information. As Bernard mentioned, you have external feeds. You can send this information to Splunk and other SIEMs, and also use it for many other purposes across your environment. The attack reports provide insight into the attack activity on the APIs. And what they allow you to do is dive into what happened, why that particular client attacked, and then look for more information on those particular attacks. And so it allows you then to go into forensic reporting, where you're able to drop down into the details. So for a given client, for example, which executed an attack, you're able to pull the activity for that client leading up to the attack, so you see where else that client may have touched, what paths they accessed. All this information is very interesting for you, particularly if that client is highly suspicious or end up executing an attack. You're able to see what else might have been affected during that client access to the APIs. It gives you this detail and allows you to basically paint the cookie trail, if you will, that shows where they went, what they touched, how many requests on each, and that sort of thing, to really pinpoint if a client has done something suspicious, what they actually did. The ability to comply with regulations, other kinds of things I mentioned, is an important part. From a forensic standpoint, we are able to do this across a number of different components. So you can do it on an API key basis, an IP basis, a token basis, or even a user basis, are all available to look and see from a forensics perspective what happened for a given client. So with that, Bernard, I
take it back. Okay, so I'm going to go into the section on detecting bad traffic and good traffic, right? Let's start by looking at how things. So we use AI to model the traffic on each API. We use also AI to model the user behavior with the API, and then we use AI as well to look at how these things correlate with each other, right? So I mentioned no rules or policies earlier because everything is self-learned. The models that are built and constantly getting built as the system runs give us a really good indication of what's normal traffic. Then we look for anything that's abnormal at that point. So from a deployment model, we could be in front of a bunch of APIs inline. That could be, for example, in a very large cloud where the APIs are directly implemented on Tomcat or WebLogic, and the traffic is sent to clusters of AI engines. Or this could be actually an API gateway or cluster of API gateways. And we'll talk about later how many API gateway vendors actually integrated with this already. It's about 11, close to 12 right now. So the thing we're looking for, right, is the behavior by the user with a token, with a cookie, with an API key. And then when we recognize a threat, you have the ability to configure the system to automatically block it. And you will be able to block on a token value, block on a API key, a cookie, or user by name, right? So we'll go into more detail next on all of these. Dore started to talk about Decoy Api and API honeypots. I have a slide on that coming up in a moment, so I won't spend too much time with this. But the point I want to leave you with on this too is that we use AI, so we don't care about traffic patterns, right? We're not looking for something that match a file template. We look for abnormal behavior. So what typically happens, you recognize the hack, you block it, the hacker automated machine now change the attack type and come back immediately with a different sequence. And as it does that, typically if you had built a rule to stop it, it now bypasses the rule. AI allows you to recognize attacks that are continuously changing. So the hacker will be blocked. He's not stupid. He knows I get blocked. And automatically his machine will adapt and create a new attack on the spot. And you have to be able to recognize the new one and block it again as well. So the beauty with AI is that the attack can be changing. It doesn't matter to us. Okay? So we'll talk more about that later. But anything that we do is within a cloud, across cloud, hybrid. So whenever we recognize an attack in the cloud, we can propagate the information about that cloud to the other clouds so that they also block the hacker if he comes back through another route. Okay? So let's talk a little bit about AI and the amount of work that goes in. As I said before, looking for a needle in a haystack is a bit like saying it's a big data problem, right? You're looking for a lot of data at a lot of different stages. So what we do today, right, we can look at a client on one API, a client on many APIs, multiple client on one API, multiple client on many APIs, all being used by different hackers or by the same hacker. And so in order to recognize something that's bad, you got to be able to understand the behavior on the API. And typically you can model that quite well because you understand the application that are using them. But you can also model the user behavior on those APIs, as well as the cross-API behavior. And so we look at a lot of data, obviously, very fast. We actually ended up building our own AI engines, and all the algorithms are proprietary and filing for a ton of patent, because you cannot do this at scale with an open source AI engine. It's impossible. So we build an AI engine that's optimized for API, high traffic, high scale, multi-cloud, and that's what we use, obviously, to be able to detect misbehavior. Okay, I'm going to move on to the next so that we have more time. By the way, very often we are being asked, as you build the models, right, those models are built, typically they get built in pre-prod, right? So you test environment, then it goes into pre-production, and then it's in pre-prod, and then you go to production. So very often we're asked, all the models that were built in pre-prod, can I bring them into production? And the answer is yes, you could build these models in production. Okay, so let's talk about bad traffic, right? So bad traffic is not always hacking, right? Bad traffic can be many other things. It could be a system that's totally misbehaving, went berserk, misfire, depending on who you talk to, different terms, right? And it starts sending a lot of requests very fast to an API, and it's literally taking the API down or affecting his bandwidth. That's bad traffic. And if you're in DevOps or security, you want to know about that. Well, typically today, it's a hunting job. You will not see it very, very fast, okay? Bad traffic can be an API misuse. Let me go back to Facebook and the Cambridge Analytica. They had right to use that API. They paid for it. But they didn't have the right to use it in the way they did. And they did get away with it, right? Because no one internally at Facebook could recognize this bad traffic. It was all legitimate. It was all paid for. They had an account. But they used an API in a way they were not supposed to. Okay? And a lot of people call it API misuse, API abuse, different terms. But it's bad traffic. By the way, another type of bad API traffic is when your application, the API itself, return data accidentally because of a bug to the wrong person. So I have a user account, I'm asking for data, and I'm getting the data from someone else by mistake because of a bug in the traffic, a bug in the API. That's also bad traffic. It's not malicious, it's not an attack, but you want to know about it, right? And then you have the case of insider abuse, where you have an employee who is accessing a bunch of stuff in a way that he shouldn't be accessing them. He may have the right to do it, but he's not authorized to do what he's doing with it. It's kind of similar to the Cambridge Analytica one. And then, of course, you have what we just talked about, right? The actual targeted threat and the attack. So I'm pointing this out because when we talk to the teams, usually the first problem is not, I want to detect the hacker. It's more, I want to know about the bad traffic, and I want to know what's good and what's bad out there. So we'll give you that. Okay, I'm not going to go through all of this, but we have algorithms that can detect a whole lot of different use case scenarios that are linked to attacks and threats and so forth. And we do this, as I said, across APIs. And by the way, if you had an attack that was on a low scale happening in AWS, and you had the same attack happening on low scale in Azure. In fact, I was with a customer yesterday, Azure, AWS on-premise, and then low scale on-premise. Individually in each, you probably not recognize anything. But as you correlate all three, you now see a pattern and you can recognize the attack. And that's what we can do. Okay, so deception, also called honeypot. This is what Dore was talking about. So deception is when you use an API that is fake. It's not a real API. It is not an API used by one of your applications. It's a decoy. Now the beauty with a decoy, remember one of the first slides I used, I told you hackers love probing. They love to try every API. They like to force errors on API. So when hackers are going on your site and assign to you, I see this API, and they start touching all the APIs, inevitably they're going to touch Decoy API, a fake API. And guess what? The only thing or person that can touch a fake API is a hacker, because you know your applications are not going to use them. So you can instantly recognize the hacking. We can identify the source. And obviously, we can then block any access to a production API from there on. So Decoy API is obviously mostly of interest to a security team, not DevOps, very useful. And what we have heard customers doing is all of these accesses, typically is pre-login, you have an IP address. It can be post-login too, but it's typically pre-login. They can now load those IP addresses that were hitting the decoy into their edge load balancer, an F5 or an Scaler, and block those addresses at the edge, so that they are not even making into the internal mesh. Okay, so last part, and I have 12 minutes. Last part is about deployment, right? So this is all Linux code, Red Hat and Ubuntu, and deployed via Docker containers with Kubernetes or OpenShift. It's all certified. VM machines, so all virtual machines out there, and bare metal. Obviously, what we typically see is AWS, Azure, and containers, right? But VMs too. And any orchestration engine can be used to automate things. We use a lot Ansible ourselves, but you can pick the one you prefer. And let's talk a little bit about the two types. You remember with one slide that showed you we can be inline in the traffic, or we can be with a gateway. So if you're inline, typically that's your only choice when you have the APIs implemented directly on WebLogic, for example, in a big cloud, or you can deploy it on the side. The nice thing about being on the side, like this one, we call that the sideband deployment, is that you can actually drop this into an existing deployment without disrupting your network infrastructure. So it's fully deployed. You could have IBM gateways, Axway gateways, you can have Nginx Plus. You just drop it in, and you don't have to dismantle your network configuration. Ping access obviously is supported the same way. We give visibility, traffic visibility to ping access, by the way, with this, which is really cool. Okay, from a deployment point of view, typically you'll deploy it, you turn on the auto-discovery, we start auto-discovering the traffic and finding out what's out there. Then out of that, right away, you start getting the true traffic visibility, the dashboard are active, the reports start to be active, and we start building the models. And the models building is based on both volume of traffic and time. So you want enough time, but you want enough volume as well. And when that's built, right, you start the attack detection, and you have the ability to identify bad behavior on the API and report that. So that's typically the three phases in a deployment. But as I mentioned earlier, right, you have no rules to write. It's auto-configured. So you don't have to feed the definition of the API, which can be a lot of work. And almost all deployment is automated. So large-scale enterprise, multiple clusters of API gateways. They could be all in the same data center. They could be in multiple data centers. This AI engine at the bottom will actually correlate and do the analytics across all of the API traffic, across all the data centers, across all the clusters. And the beauty with this is not just that visibility, but you are able to detect a very slow-moving attack in a data center that will not be visible otherwise. Okay? So moving on. These are the sideband policies that we have today. And there are a few more being deployed, being finalized right now. But layer 7, IBM API Connect, Data Power, AWS, Azure, IPG, MuleSoft, and WSO2, Nginx all done. A few more coming up, like Software AG, TIBCO coming up, Red Hat coming up as well. We've done a lot of work with Red Hat, by the way. When we are inline, we support any API gateway. We can put it in front or in the back, doesn't matter. We've done a lot of work with TIBCO. We've done a lot of work with Red Hat. In fact, Red Hat has a landing page on their own site about protection of API with 3Scale. And we're doing more with them, but there's ICANN also coming up and so forth. So you can see how we kind of did a good job there. And by the way, these sideband policies, many times they were developed by them. IBM developed the integration with us, for example. WSO2 developed the integration. It was not always us. And then App Server supported directly as well. So that gives you an idea of what we support and what's available. Okay? For those of you who were familiar with our solution already, PingIntelligence for API, we're just coming up this week with a new version 4.0. So we thought we'd put a slide up for those who are already familiar so that we can highlight for you what's new, what's coming up this week. So in 4.0, we added the ability to do the modeling around the API sequencing. So remember I mentioned that hackers love to bypass a UI, go straight to the API, and now they're starting to use the APIs randomly. So we actually build AI modeling to model how an application actually sequence through the APIs. So depending on the user, depending on the application and so forth, it will be different. But we actually can model the API sequencing. So when a hacker starts bypassing a UI and goes straight to the APIs, we'll be able to recognize that. The other thing that we did, we're now tying identity to API traffic. And we can now build reports that have the user identity next to its token, next to its cookie, next to that API key. And we can do a whole bunch of user behavior modeling around that as well. But now the beauty is you run a report and you have the user name right next to it. And then we did a whole bunch of other stuff. We keep adding stuff on attacks. So we added a whole bunch around the API header manipulations that hackers do. More dashboard, more capability around managing the attack list. We didn't go into a lot of details, but the attack lists are really blacklist of bad token, bad IP, bad cookie, bad users. And we can give life to this. For example, if you captured an IP is bad today, in 3 months the DSP is pretty good. So we build the ability to put a life timing to some of this stuff. And then we build a whole bunch of script in 4.0 to automatically do things. So you see something in a threshold, in a dashboard, and you want to do something about it, we have script that let you automate a ton of stuff. Okay, so that's 4.0. It's coming out this week. Okay, so let's talk about the future, right? Future is about microservices. And if you're not there yet, I can guarantee you that in a couple of years, 3 years, you will be there. Netflix run on microservices, for example, right? And a modern mesh architecture uses this. So in a microservice environment, your point of entry, right, that point of ingress is an API. And just like we have done for the gateways, we can use, we can use that point of ingress to grab enough information on the API traffic to also assess whether certain bad things are happening with that traffic. So moving forward, you'll see us integrating into some of those microservice architecture through, if you're familiar with the term, Istio and Sidecar. All right? Okay, summary slide, and leave me 5 minutes for, do you want to go back to the demo, Dore, at this point? Okay, so back to Dore right now. Can you switch back to the demo? Thank you.
So where we left this was we were trying attempts to access, Is it showing? Ah, there it goes. We're trying to access the API, and you saw we tried many different things. So we kept trying different passes and passing different information each time as guesses. We reached a point, and now every single transaction is blocked. So basically, During this session, it detected the anomalous activity and found it was significant enough to constitute attack, and now has blocked that user, so no longer have access to the API. And so not able to extract more data.
So this is an example of an attack that was sent on an API, and the system recognized the threat and ended up starting to block systematically every request done by the hacker. And remember, the test was fully automated, but that's how hackers do, right? They fully automate the attack. The idea of a hacker behind a keyboard in a dark room with a mask on him, that's no longer true. It's really fully automated machine that use AI and ML themselves, by the way. Anyway, let's, I need to switch back to the presentation. Thank you. Okay, so we talked about three things, right, today. We talked about PingIntelligence for APIs that can give you this deep traffic visibility, recognize all the APIs, all the URLs. By the way, we recognize all of the API names that the hackers are trying on the system. And we give that to you in a report. And then you can use this to create Decoy APIs. Because that's the name they try. Create an API with that name, and you're going to catch a hacker. We also talked about the automated threat detection and blocking, the AI that we use and all the algorithm to understand good from bad traffic and block threats. We talked about the honeypot, just again. And then our ability, right, to deploy this in any cloud, hybrid cloud environment, and give you this view across all of those environments with gateways, with application server, or with ping access. So it's kind of the culmination of about 5 years of work there, to tell the truth. And API infrastructures are growing because just about everything in the future will be front-ended with an API. So having the ability to see the traffic, understand the traffic, and highlight the good from the bad is going to be critical to all of you. All right, so that's it for the presentation. If you have any questions, we have 2 minutes. Yes?
Quick question on the, it looks like your assumption is with REST APIs, so there's, we're coming out with a lot of GraphQL APIs, gRPC, streaming APIs. Does your model support those other things?
Yeah, we do REST and WebSocket today. So we support streaming APIs, but we are moving on to GraphQL as well and so forth, so we're starting. But today, REST and WebSocket, we didn't go into too much detail, but any WebSocket traffic would be analyzed the same way.
And similarly, a lot of our attacks are at the layer 7, kind of in the payloads. So if we're pushing a lot of our payload with sensitive or secret data to the solution, isn't that a security concern? Or do you look at layer 7 sort of vulnerabilities or more?
So both. So it's a really good question. The question was about layer 7 and looking at the data payload. We have another product called PingDataGov. And PingDataGov, we essentially work on a control path. PingDataGov essentially work on a data plane, data path. And PingDataGov can recognize the type of data that is going across and can enforce policies on that data. So if data was being accessed by someone who doesn't have the right to that data, it could be the policy will go into effect and block that access. So we have 2 products, 2 different things. Any other questions?
Yeah.
Oh, sorry. Thank you.
How do you tell not to trigger on stress testing?
On stress testing, it depends on the type of stress testing that's done, to tell the truth. But if you were doing, well, Dore, you want to take that question if you want?
Well, a couple options. If you know where it's coming from, you could actually whitelist the stress testing would be one option. If you don't, then we could talk maybe about other ideas.
Yeah. Or you could start a stress testing and then unblock. You know all the stuff that was blocked, you can start a routine that will unblock that.
Okay.
Okay, any other question? Yes?
I think if I understand correctly, there was 3 deployment models. There was an inline, a sideband, and the third model would be the ping gateway itself.
Yeah, so really 2, because the sideband is on the gateway. So we can be in front of the gateway or behind, or we can be on the side of the gateway with a sideband.
So on slide 23, you showed things getting like metadata from,
Yes.
I don't know if that was a third-party gateway or not.
Yeah, these are all third-party gateways, so it could be any vendor's gateway.
So the question I wanted to ask is,
Yeah.
across the three deployment models, is the functionality the same?
It's the same,
Okay.
always. And you can mix, we have a lot of customers who have mixed API gateway environment because different business units bought different things. It doesn't matter to us. We can link them all through a cluster of AI engine and we can sort out the traffic across all of them.
Can you talk about the performance impacts and benchmarks?
I couldn't hear, sorry.
Sorry, for the, I guess, the intelligence and data collection.
Yeah.
What are the incremental performance?
Oh, the performance impact of doing it. Not much because a lot of the code we built was in C++ with extremely low latency type characteristic. Even in line, we depending on the type of traffic, with MQTT traffic, which is very small payload, it's like half a millisecond of latency. With more, it could be 3, 4, 5. On average, we see in line 6 milliseconds. When you're on the side, we don't touch the data keeps going. We look at the metadata on the traffic, so depending on the side and the implementation, it's also very negligible. Yes?
How does it play with the data governance? So we were looking at this as an access control mechanism.
Yeah.
We want to have both handcraft policies on you guys and this multi-control protection. So how does that play in the policy?
Yeah, so there are two products that can work together, but they are independent. So ping.gov will have a graphical policy editor that will let you decide what policies to when and so forth. We observe the metadata on the traffic ourselves, so we don't look at the payload. So the two can work together, join under heap without affecting each other. Any other question?
Right here.
One more.
I actually have two. But
Okay, now go ahead.
They're quick. So the first one, do you have a timeline for software AG support?
They are working on it themselves right now. And though you were tracking this more than I have.
I'd say Q3 timeframe is we're hopeful to have something out, but
Okay. And the software AG has like a legacy SOAP support.
Yes.
Are you going to support that as well?
We don't support SOAP, but we've been we've been drawn into looking at supporting SOAP by a couple of customers.
No, I'm just asking because
I know, yeah.
the software AG has
Yeah.
SOAP.
And we know, yeah. That's right.
All right.
Thank you. Yeah, absolutely. All right. Good. So thank you for being here.